They said you wouldn't make. They said you wouldn't make it so far.
Are you interested in finding a school to enhance your education? Not sure where to start? Well, today your search is over. CDP Maths Lab eSchool offers classes for C.S.E.C, CAPE, and GSET subjects, along with training in early childhood education and data operation. Listen to what CDP Maths Lab students have to say about their most fulfilling experience.
While I was attending, it was almost the best experience I ever had. Like I was in class, but I wasn't. I would give the school the full 10 out of 10 because the teachers take the opportunity to help the ones that really needed it. To the upcoming students, this is the best decision you have made and it will benefit you in the near future.
Just talk to your soul and say, I can.
CDP Maths Lab eSchool was founded by Ronique Bernard in August 2009 with a vision to see our students receive a solid education with an emphasis on developing their cognitive skills. The school is committed to developing individuals who will have a positive impact on the society.
The class it really helped me, and if you are going to see C.S.E.C, I really recommend this class, so you could always give it a try. The prices are really reasonable, and it is really worth it for online class. Like myself, you would be proud because on that day or on that night when results are out and you log in and you open your results, that feeling, it really is great. It is more of an experience that you would really want to relive.
Of course, I went through it and I passed my exams, so I would highly recommend this to anyone. If you have a problem or so, they will take their time out. They will take their time out to tell you. Plus, they have history of also past students who have also passed their exams in once.
I've been attending for 6 months, and my most fulfilling moment would be the interaction between the teachers and the students, as the environment is very comfortable and welcoming. On a scale of 1 to 10, with 10 being the highest, I would rate this institution, along with the teaching techniques, skills, and tolerance of the teachers, a perfect score of 10. If I had the opportunity to recommend someone to this class, I would, because I can assure you that you will leave 10 times better than how you had entered. Now that I am leaving, one thing that I would recommend is a classroom interaction at least twice a month, as some students tend to do better with face-to-face interactions. This program would be the best decision one could choose, as the teachers are excellent at what they do, and they will go to the extreme to ensure that you understand what was taught, even if that means staying up with you all night. To CDP Maths Lab, thank you.
Despite his late start, Shonday was able to successfully complete his exam.
Trust me, it's a really good program, because if I entered a month before exam and I passed the exam, that says everything for itself. The program speaks for itself practically then.
Just start to believe.
CDP Maths Lab eSchool is convenient and economical. We provide flexible learning options in a relaxed environment. With over 80% pass rate, we offer free demo classes before payment, one-to-one interactive tutoring, clinical teaching sessions to strengthen weak areas, and step-by-step video and worksheet exercises.
So of course, we really are the one to choose.
Okay, good night everyone. All right, good night to another maths class. As we continue tonight in our Monday night's class, Mr. Foster will not be able to be with us tonight. So I will take over this evening and continue from where he left off. So good night to you all. Everybody's not here. Tarsha is trying to get in, or is it Tarsha is in? All right, so good night, Queen. Good night, Tangini. All right, good night, Tarsha. I think you're trying to get in. All right.
That's
Okay. I want to say a good night to those persons who are watching us live from YouTube. Good night to Young DK out. Mr. Bernard here speaking. Good night to the other 3 persons or more who are viewing us live on YouTube. Now, what's on for tonight? Of course, we'll be continuing circle theorem. We have some worksheets to do, 2 worksheets based on circle theorem. We have some notes to get, but as we get into the class, I'll say more. So we're going to begin our devotion, our classes with devotion first. This is for those persons who are coming in for the first time. The class, well, we are scheduled to finish at 10 o'clock. Young DKO, not exactly 2 hours, but scheduled to finish at 10 o'clock. All right. Now, so I'm just saying that if you are coming for the very first time, persons who are watching live from YouTube, if you're coming for the first time, our standard is to begin our class with a devotion. We strongly believe that we can only do everything through Christ who strengthen us. Strengthen us not only physically, but not only spiritually, but physically and of course mentally. And we do desire that mental strength through Christ. And so we are going to begin our devotion first. Now, tonight's devotional text comes from the book of Deuteronomy, chapter 28, verses 1 and 2. It says, now, just to give you a backdrop of where this text is going, this is God speaking. Moses is the one who wrote this book along with Genesis. So he wrote the book of Deuteronomy. But let's hear what he has to say to the children of Israel at that time. It says, if you fully obey the Lord your God, and the word if suggests a condition. If you fully obey the Lord your God and carefully follow his commands I give you today, the Lord your God will set you high above all the nations on earth, and all the blessings will come on you and accompany you if you obey the Lord your God. This is saying to me that our blessings, that the blessings of the Lord is based on our obedience to God. So it says, if you fully, not halfway, not quarter way, not a third, but a whole, if you fully obey the Lord your God and carefully follow all his commands, I give you today, the Lord your God will set you high above all the nations on earth, and all these blessings will come on you and accompany you if you obey the Lord your God. So again, We have seen it repeated twice. Obeying the Lord your God. So it's important that we obey God, that we may be blessed according to his promises that he has made. Now, before we pray good night, Nikosha, we are going to listen to our theme song to prepare our minds for our classes.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God. 'Cause all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice. You will lead me through the fire, and in darkest night you were close like no other. I've known you as a father, I've known you as a friend, and I have lived in the goodness of God, yeah. And all my life you have been faithful. Oh, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God, yeah. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Oh, your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running, it keeps running after me. And all my life you have been faithful, and all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. I'm gonna sing, I'm gonna sing. Oh, 'cause all my life you have been faithful, and all my life you have been so, so
Yeah, let us pray. Our Father, who art in heaven, hallowed be your name, dear God. Father, we come before you not as saints, but as sinners who are in need of your saving grace. We pray and ask, dear Lord, for forgiveness of our sins that we have trespassed against thee, as as you as we forgive those who have trespassed against us. And Father, I want to put before you the students in Zoom, students who are part of CDP Lazarus services, the students who are watching from YouTube, and the students across the Caribbean who are preparing for this exam. Father, you are the only one who can help them to be prepared. And as they study and as they practice, pray, oh God, that you'll develop their cognitive abilities. Pray, oh God, that you will continue to inspire them, to motivate them, to provide them with the mental power, the physical strength, and of course, the spiritual strength that they need, dear Lord. Pray that you'll allow these powers to be developed harmoniously, that they will experience true education. At the end of the day, may they become your chosen ones that you will use to continue to reflect your image. In Jesus' name we pray. Amen. All right, so we're going to move into our class time. And as said before, we're going to proceed with circle theorem and continue with this class. Now, good night, Lexi. No, Lexi's not yet on yet. All right, so I just want to say good night again to you all. The clock is ticking, but with God, all things are possible. There's still time to be prepared for exams. Students have used a month and prepared for exams. So we're still in good shape to be ready for exams. However, just want to say to you, just remind you and those who are on YouTube that our marathon class begins tomorrow. We'll start a bit late tomorrow though. The time will be, yes, good night, Lexi. The time will be 8:30. And of course, on Wednesday night, we'll begin earlier at 7 p.m. and finish around 10 o'clock, 10:30 thereabout. And we'll be looking at vectors, a lot of vector questions, more information on vectors. And of course, we'll continue with our multiple choice quizzes. Tonight will not be a multiple choice quiz, but certainly every night during the marathon, you'll continue to get your paper one type questions. And of course, each night is a new section of the syllabus. So tomorrow we'll be looking at vectors, and the next day we'll be going on matrices, and we're going up this time. So over these 2 weeks, we should be finished with the syllabus. And then we go into June just to freestyle, look at some other questions and ensure that you're ready for the exams. But still continue, so those students here in Zoom, still continue to try getting those assignments done. I mean, I know for those who are at high school that you have other subjects preparing for as well, but now it's time to really call for a study timetable that you may manage your time well. So it's very, very important that you manage your time well. All right, so we're going to start off with our notes on circle theorem, just to provide you with some notes. So just in case I didn't record the notes before, then you have some notes here. Now, some interesting things about angles, and circles. Now, normally when I teach circle theorem, I never normally give my students notes, to be honest with you. Never normally did that. What I normally would do is ask, and I think Lexi can testify to that. My strategy for circle theorem is to encourage you to use your geometry set. The geometry set is a decent calculator. Yes, and you'll be seeing how ensure to have a geometry set and a scientific calculator for the marathon. Ensure to have it. Remember to have your graph leaves for the marathon, especially for tomorrow. You will need your graph leaf for tomorrow. Very important. I don't want my students to go into the exam to rely on memory. That fails students often. Do not try to rely on memory. You want to try to rely on building on simple information to discover the answers for complex questions. Good. That is what I want to train you to do. Continue to train you to do, and over the next 2 weeks for mathematics. So I'm going to ask you, please ensure to have a geometry set, your graph leaves for tomorrow, pencil, ruler, everything that you need for tomorrow's class. Very important. Tomorrow is a work class, as we'll be doing tonight. But I didn't tell you to walk with the geometry sets tonight or have them by your side. Walk with them, have them by your side. All right, let's continue. Now we start out by talking about an inscribed angle. Now, by way of looking at this, is an inscribed angle. It's an angle made from points sitting on the circle's circumference. And of course, we know the circumference of a circle by now, which is this line. Good. So any point sitting on the circle's circumference, or any angle rather, good, made from points sitting on the circle's circumference is referred to as an inscribed angle. Got that? Everybody got that? Answer yes or no, please.
Yes, sir.
Yes, sir.
Okay, thank you very much. All right. Now, I am like a pastor. If I am at church and I do your amen, I don't feel that the church is awake. So if I don't hear my students them answer me, I don't feel like my class is awake. Okay, so please answer yes or no. All right. Now, QN, do you want the opportunity to play with this, or should I be the one to do it? QN? QN, are you there?
Yes, sir.
Yeah, you want the opportunity to play around with this, or you want?
You can go on do what you do. Let me see first.
No, man, nothing difficult in it, but it said drag the point. That's all it did, drag the point. All right, so I'm going to drag the point for you to see what happens here. But note the question. They say when you move point B, what happens to the angle? Now, before we go into that though, I wanted to acknowledge certain different parts of the circle. So one, we have a chord. So the line segment CB or BC rather is a chord. The line segment AB is also a chord. And the angle inscribed is what? B. Good. Now let me ask you now to use your eyes, because you know I love when my students use their eyes. The angle B, could you describe where it is formed apart from on the circumference? Hello? Where is it formed? Anybody? Those in YouTube can answer as well. Where is the angle formed? What preposition could you use to describe the location of the angle? Any prepositions you could use to describe the location of the angle? Anybody? Q&A, your mic is muted if you're speaking. Nobody? All right, let's go back again. This line BC is a chord. This line AB is also another chord. So the question is, would you describe the location of the angle B? Nobody? Would somebody try and give an answer? All right, so Lexi is saying on the arc. Well, it's on the circumference. It's on the circumference. All right, nice try, Lexi. Nice try. Anybody else wish to try? All right, let me help you out. It is between the two cards. You don't see that? It's between the two cards. The angle is, that's why I wanted to use the eyes. Use the eyes. So this angle is formed between the two cards. All right, let's look at what happens when we move it. What happens when we reach the point C? What happens when
The angle change.
the angle changes? But
Yes,
the
sir.
angle changes and the angle also what? The angle changes, but it's also what? It changes and also. Oh, this is C. We're moving C. Eh? We want back. All right, let's go back C where it's supposed to go. So the angle changes whenever it reaches C, right? But at the point B. So it changes. So what you observe? Observe anything special?
Sir, is a specific angle, is a specific value. The angle is a specific value on either side of both of the cards, if that makes sense.
Well, okay. All right. So, but when it reaches point C, the value of it increases, right? Good. But
Yes, sir.
it doesn't matter where on the circumference, the angle doesn't change. See that? Now, if we continue, it is now 98 degrees here, but above here, it was 82. Is there a reason for that? All right, let's do some investigation here. What you observe? Observe anything? Any observation? If I move this lens, anything special? Yeah, go ahead, Kirin.
The farther you move point C
Mm-hmm.
away from point A in an and in a clockwise direction of the circumference, the the value of angle B is what it is. It increase.
Right, let's see. Let's see. If I move it closer,
Oh yes, if you move it closer, it increase, and if you move it away further, it decrease.
decreases.
Yes, sir.
Okay. So the length of this angle here makes a difference. Good. Makes a difference. I want to get some more information about it, but I just wanted to observe most of the theorems that we're studying now, the circle theorems that we're actually studying now, came from actually experiments. They have been studying circles, and and based on the pattern, they have discovered and then now theorized these theorems, just like how you're trying to theorize now. That's the kind of experience. Good. So that's why when I teach circle theorem, I allow my students them to redraw the circles for themselves of different sizes to test the theorem to say the theorem is true. Make sense? So I don't like to tell the theorem. I like for you to test the theorem for yourself. All right? Good. And you'll discover more. Look at this now. Okay. So we find a 90-degree angle here. Now there's a missing information that you don't know as yet. But one thing we can say is that there is a difference in length. Good? Making sense? The two line segments, they are different in length. And we also, we can assume that the line from C to A is possible at the diameter, right? But it would have been better if you draw your own circle, use a protractor and your ruler to measure the lengths and study it. But let us go further and get a deeper understanding of what's going on. All right. Now, this is considered to be one of the theorems. Can somebody read the statement here, please? Tangini, we hear Queen, Tangini, Alexia, Tasha, Nikosha. Can one of you read this one, please?
An inscribed angle A is half of the central angle 2A.
Okay. And what does that mean to you? What does that mean to you?
So that A is half of 2A.
Okay. For example, do you want to give an example to explain? For example,
If the central point is 8 and the angle on the circumference is 2.
so,
No,
so
sorry. If the The central point is A, and the point on the circumference is A. You want to find half of the central point to find A, if that makes sense.
Well, if you're going to explain, well, try. A point doesn't make sense to you, so try and make it, allow it to make sense to you. Then it will make sense to us. So try again. Give a different example. Try again, Tangini. Mhm.
For example, 2x then, and the point on the circumference is x. So to find x, you have to find out what is 2x, and then to find x, you have to so something like algebra.
Okay, all right. You see, that's the problem. You're being too literal. And this is what many students make the mistakes. You have to find meaning from the theorem. If you don't get find meaning for yourself, then you're going to have problems, right? All right, but nice try. Would somebody else want to try to express what this statement means to you by giving an example?
Sure.
Yes, Tarsha, go ahead.
What I get so far is that if 2a if 2a is 40, it would be 20.
Exactly. Good. So if 2a was 40, a would be what? 20. Yeah, you see how that was done, Tangini?
Yes, sir.
What she says, if 2a was 40, then a will be 20. That means that you understand. So let me ask the question now. What if a was 30 degrees? What would 2a be? If a was 30 degrees, what would 2a be? Huh?
60.
60. All right, good. All right, wonderful. All right, so this is called the angle at the center theorem. Good. Now the angle A is always the same. And you'd have seen that the angle A is always the same. And you'd have seen that in this activity here. Always the same. Why? Let's look at it. Angle A is always the same, no matter where it is on the same arc. No matter where it is on the same arc between the endpoints. So let's look at it. On the same arc between the endpoints. So here are the endpoints. And they are on the same one, arc. So this is two different arcs, you know. Let me make note of that. This right here is one arc. Good. And then let's use a different color. This major arc here is another arc. Good. Now, this point and these two endpoints is on the same arc as this one. So it's not going to change. Making sense? Making sense? And how they discover that is that they draw different circles and put the point at different places on the arc and measure the angle with the protractor, and you recognize that the angle doesn't change. Good. All right, persons in the chat, you can also respond to the questions. So don't just sit there quietly watching. Okay, good night, Teresa. Good night, Gabriel. The angle B is formed between the two cards, BC and AB. Very good response, Gabriel. I'm just seeing it. Sorry about that. And good night to you again, Teresa. All right, so let's continue. All right. Okay, so remember now, students, that you must get meaning. Don't just read the theorem and the angle at the center is 2 times the angle. No, get meaning from it. Good. Make it make sense to you before you proceed any further. All right. Now, just by looking at these circles here, well, I kind of give it away already. Please note something. Please note something. How many cards are we looking at on the circle? How many cards? How many cards are we looking at on the circle there? How many cards? How many cards?
Sir, 2.
2. Okay, I'm hearing 2. Anybody else? Anybody else? How many cards?
4, sir.
Lex says 4. Okay, Lex says 4. Anybody else? Lex says 4. Anybody else? By the way, what is a card? What is a card? What is a card? If I tell you that this line is a card, this line is a card, this line is a card, and this line is a card. So we have 1, 2, 3, and 4. So that was correct. But if I tell that these are cards, then how could you define a card? Yes, go ahead, Kirin. Kirin, you were speaking?
No, sir, but I'll give it a try.
Okay.
A card is a straight line drawn from 2 points of the circumference of a circle.
Excellent. Excellent. That's why I wanted to use the eyes. You see, when you use the eyes, these questions will not beat you any at all. You understand? So the eyes are very important. The eyes are very important. So a chord is any straight line, as it clearly says, running from one point on the circumference to another point on the circumference. And all the chords does the same thing. True? Now, what is so special about the angle A? What's so special about the angle A? Is there anything special about them?
So both of them, they're being drawn from the same 2 points of the circumference.
Well, no, not really. Repeat that one again. Repeat that one again. Repeat what you just said about again.
Both of the angle A's, they're formed from drawing lines that start at the same 2 points.
The same 2 points. What you mean?
Like where your mouse is at right now.
You mean right here?
Yes, sir.
Mm-hmm.
And if you go a bit left,
Here.
yes,
Mm-hmm.
yes, sir. So if you the line that the line that goes from there,
Mm-hmm.
it creates both of those angle A's with the one line going up for the seemingly bigger one, and the
Mm-hmm.
next line meeting that one. Yes, it's kind of
Oh, you mean this line and this line?
yes, sir.
Okay, okay. All right, okay. Any other observation by anyone else? Come students, you have to learn to use your eyes. Very important to use your eyes. Okay, somebody text an answer here. They're in the same segment. Okay. Very good observation, Lexi. They are in the same segment. Very good. They're in the same segment. All right, wonderful. Yes, they're in the same segment. Could you tell the class what a segment is? That's a big word. What we mean by segment? They're in the same segment. That is true. That is so true. All right, so they're in the same segment. Any other definition?
Sure, they are both formed on the circumference.
Well, yes, they are both formed on the circumference. Yes. All right. Any other? Any other? Any other? Any other? So would you say that they're opposite to each other? Would you say they're opposite to each other? Anybody?
Sir, and answer. Sure, you could say that.
Mhm.
Uh, any angle could be opposite to any angle if you look at it from an angle.
Mhm.
of-
Okay, but would you say that they are parallel? These two cards here, this card here and this card here, is parallel to each other. Would you say that?
yeah, they look parallel to me.
Look parallel. Okay, all right.
I
Good.
would say that.
What you say, Lexi?
Yes, sir, I would say that.
They say yes. Okay, and of course, as Lexi says, they are in the same segment. But there's a word used that there's because in the exam, and this is one of the reasons why I want to express yourself. Because in the exam, they not only ask you to to determine the angle, but they also ask you to give the reason. And normally the reason that you're going to give is normally backed up by the theorem. But if you want to further explain yourself by observation, that would be good. Good. So don't sit in the class and just be quiet. Try. This is the time to get the answer wrong. This is the time to try if your skills are being developed. You understand? So ensure to do that. All right, good. So good observation so far. Now they are saying to us that the angle A is the same, which is obvious. If you measure it with a protractor, you'd have seen that. The angle subtended by same arc. No. What does the word subtended mean? Subtended. What does the word subtended mean? What we have to put this thing. They are subtended by the same arc. They are subtended by the same arc. What does the word subtended mean?
So like formed.
Formed? Well, no, no, no. Well, let's look at the definition that the Merriam-Webster gives. And it can be used as a transitive verb, which means to be opposite to. To be opposite to. And extend from one side to the other. From one side to the other. Now, here's an arc. So the arc there? You see the arc? Now, we're going to test out something. Let us test out something. Let us test out something. All right. So here we have angles in the same segment. Angles in the same segment. Let's look at this. Angles in the same segment. Now, what they are saying here, angles subtended by the same chord within the same segment are equal. So note that this angle here, this is the line that is highlighted. Good. This is the line that is highlighted. Hold on there. So these angles here are subtended by this chord. And they're in the same segment as it heard Lexi said. Good. So note that, you know. Note that. So angles subtended by the same chord within the same segment are equal. All right. So I move the point around to see this. And let's look at it. This is 90 degrees, right? No, this is 90 degrees. Now, my question now, is this angle equal to this angle? Doesn't look like that, don't it? But, all right. Let's continue to see what happens. All right, this may not be clear to you as yet. All right, now if you have a geometry set, we're going to test these theories with the geometry set for you to see for yourself. But the only way you're going to actually appreciate the theorem is if you test it with your geometry set. Is that clear? Is that clear?
Yes, sir.
Okay. All right. All right. Now let's just go back to, oh, welcome there, Torpedo. Welcome. All right. Let us go back to this. So as Lexi said before, that both these angles are in the same segment. And both these angles are under the same card. Good. But if you look at the same arc from here to here, they're on the same arc technically. Good. So they are subtended by the same arc. So yes, they're going to be what? Equal. All right. Now, let's go further now. Let's look at some examples. Now let's say, what is the size of the angle OQ? Now normally the middle letter is the angle that they are making reference to. Good. Now, the angle R is 62 degrees. So by principle, they are saying to us that the angle at the center here, opposite and underneath it, would be twice the angle here. So hence multiply it by 2. All right, that was easy. All right, let's look at this now. And what is the angle? What's the size of the angle CBX? What's the size of the angle CBX? Let's take a good look at it. CBX. What's the size of the angle CBX? So they want to find this angle right here. All right, could somebody read the first line? Could somebody read the first line?
Angle ADB equal to 32 degrees. Also equals angle ACB.
Angle ACB. So angle ACB. So this is also 32 degrees. You got that? You got that?
Yes, sir.
All right, okay. And they are subtended by the same what? Arc. You got that? All right. No. All right. So thank you very much, Lexi. So read the second one for me, please.
And the angle ACB also equals angle XCB.
All right. So angle ACB also equal to angle XCB. Well, okay. All right. So they are saying that, let's look at it now. ACB, this is the angle here, formed by ACB. This angle here is equal to XCB, same angle. Good. All right. Okay. So now, could somebody read the third one? Could somebody read the third one?
So in triangle BXC, we know angle BXC is equal to 85 degrees,
Mhm.
and the angle XCB is equal to 32 degrees.
Okay. All right. So now they use the theorem that the sum of the triangles the sum of the angles in a triangle, some of the interior angles rather in a triangle is 180 degrees. So you have to know this bit of information too. Good, because if you can find the angle at B, you'll be able to find the angle at what? A, because you know that these two are supposed to be equal, right? Make sense? Make sense? Nobody now talk to me?
Yes, sir.
Okay. Now let's call what they did now. Now angle CBX, which is CBX plus angle BXC plus angle XCB should equal to 100 and what? 80 degrees. Now, angle CBX, so they want to find this angle here. So when you
Excuse
add,
me, sir.
yeah, go ahead.
Could you let Tangi into the meeting?
Let Tangi in the meeting. Oh, thank you. All right. Now, so if when you add this angle here, so you add the known angles. So again, this is one reason why you have to use your eyes. Because if you can catch a triangle, you can make use of the triangle that's there and the information in the triangle. Good. Now, would have used a theorem, good, about the angle subtended by the same arc to know that this one is 32. So now you know that this is 32. You can add 32 to 85, and you're going to subtract that now from 180, and you'll get the angle what? 63. So if this is 63, then what is the angle A? What is the angle A? If B is 63, what is the angle of A? Angle at form at the point A. Lexi, your mic is muted. Nobody? Come through and talk. If the angle at B is 63 degrees, then what's the angle formed at the point B? That would be DAX.
Sir, repeat that.
If the angle at B here is 63 degrees, what will be the angle at A? All right, very good, Torpedo. 63. Yeah, it must be 63. It has to be 63. Because remember, they're saying that this angle subtended by the same arc is equal. So what this example is showing, you must be able to use the theorems and the knowledge that you have. Yes? Good. And that's one of the reasons why I said that you need to use a geometry set. Oh, the next time we go, and we're going to go back on circle theorem. We're going to go back on this circle theorem. But you need to use a geometry set so you can appreciate the theorems. Because I telling you the theorem, showing you the theorem, and show you how it is being used is not great benefits. It is greater benefits if you have a geometry set, redraw the circles for yourself, measure the angles them for yourself, and the lengths. Circles have 3 different sides, at most 3 different sides, and see if the size of the circle tells anything different, and catch the patterns for yourself. Then you'll be able to appreciate it more. All right. Most persons are afraid of it because they don't appreciate the theorems. That's the one reason why they're afraid of it. All right. But there's no need to be afraid of it. All right, look at another theorem now. Can somebody read this one, please?
An angle in a semicircle. An angle inscribed across a circle's diameter is always a right angle.
Okay. It's always. That means that it doesn't matter the size of the circle. Doesn't matter the size of the circle. Doesn't matter the size of the diameter. An angle inscribed across a circle's diameter is always at right angle. It's not going to change. Always at right angle. But across the diameter. So here's the diameter, and the angle is across it. Good. All right. The endpoints are either, look at this, the endpoints are either end of a circle's diameter, and the apex point can be anywhere on the circumference. Anywhere on the circumference. It's always going to be 90 degrees. So always remember that. And of course, if you redraw the circles for yourself with your protractor, your compass, your ruler, your protractor, and measure the angle with 3 different size circles, you're going to realize that this theorem is a fact. All right? They're going to appreciate it better. A question is asked, why? Could somebody read the answer to that? Because
The inscribed angle 90 degrees is half of the central angle 180 degrees using angle at the center theorem above.
okay, very good. All right, good night, Alicia. So that you're late. Good night, Torpedo. Your answer was correct, 63 degrees. All right, I don't understand when you were saying no. I don't know what you mean by the word no. What you meant by no. So could you explain, Torpedo? All right, so very good. So they were using that, using this theorem to complement this current theorem here. Good. All right. Okay, wonderful. Now they have another good reason. They said we could also rotate the shape around 180 degrees to make a right angle. And look at it and see if you're seeing it. So they rotate it, they would make a rectangle. So they could rotate the shape around a 180 degrees to make a rectangle. Now it is a rectangle because all sides are parallel and both angles are what? Equal. All right, good. Okay. All right, so they are showing you no matter where the point is, the angle will always be 90 degrees. And what I'm suggesting to you. Oh, okay, Torpedo. Okay. All right, wonderful. Now, what I'm suggesting to you is that you redraw these circles. And students, I was teaching a student from Meadowbrook High School. 2 students from Meadowbrook High School. Both of them passed the exams. And they followed the instructions. And when they came in the class and they followed my instruction, they were the ones answering all the theorem questions in the past papers, because they did what I told them to do. So I'm telling you, well, you know, I'll open to listen this time. All right. Need to listen, students. All right, let's look at this example. Now let's say, what is the size of angle BAC? Try and see if we can figure it out for yourself. Use what you have just learned a while ago. And note that if you didn't get the notes, you can always go back to the recorded session and you'll get your information. All right, if you had not taken down the notes. What is the size of angle AB, angle BAC? Try and figure it out. Using what you have just learned a while ago. You have learned two things that you can use to figure out that answer. All right. So Torpedo says something. Let's see what those persons in Zoom says. I get two Zoom responses. All right. So Lexi says that. And Nikosha says that. Okay, let's use. You sure? You're sure? You're sure? I think you should try again. What shape is inscribed in the circle? All right, Kiwin, you're right on the spot. Very good, Kiwin. That answer is correct, but you told everybody. All right, and Torpedo is also correct. Kiwin, could you explain to the class why the answer is 35?
Yes, sir. So what I did was because it said that because we just about the rule where angles that are inscribed across a diameter. Diameter, yeah, the diameter are equal to 90. So since angle ACB would be equal to 90 because the rule applies to it, then you would just need to do your regular calculations in terms of finding one missing angle out of a triangle because you already have two out of the three that you need to know to add it up to 180. So you just add 90 plus the 55, subtract it from 180, and then you get the 35.
Excellent. Excellent. So now Alexa just seen it. Excellent response. Excellent response. Very good. Excellent. So you use the rule that was just given to you. And you looked at it and notice the articulation. It applies. That is it. And that is how you're going to write your responses in the exam. Excellent. And that's why I need everybody to practice to know it's time to get your answers wrong. You have to use your eyes. It's the eyes that make the difference. You know? The eyes can make the difference. All right. Come with the eyes. Is right. So the answer is 35. There you go. So the angle in the semicircle theorem tells us that ACB is 90 degrees. Now use angles of a triangle at 200 degrees to find angle BAC. Simple. All right, very good, wonderful. All right. Finding a circle center. But I'm not sure if this theorem is going to be. All right, let's look at what they're saying here. We can use this idea to find circle center. All right, Kirin, can you read the first part, please?
Yes. Finding a circle's center. We can use this idea to find a circle center. Draw a right angle from anywhere on the circle's circumference. Then draw the diameter where the two legs hit the circle. Do that again, but for a different diameter.
All right, so this is an activity you'd have to do. So if you don't have your instruments, then you'll not be able to do that activity, all right? Also, where the diameters cross, that is the center. All right, so just in case. All right, so the cyclic quadrilateral now. Ready for that? I will know what a quadrilateral is. Any shape that has four sides. Didn't say 4 equal sides, no. So any shape that has what? 4 sides. So a cyclic quadrilateral has every vertex on a circle circumference. So you have 4 inscribed angles. Good. Now, let's look at some facts about the cyclic quadrilateral. They are saying to us that opposite angles add to 180 degrees. That's what they discovered in a cyclic quadrilateral, that opposite angles adds to 180 degrees. Make note, I'll be making notes now because the worksheet is going to require this information, and that's the reason why I started off by giving this information, right? Now, the cyclic quadrilaterals, opposite angles add to 180 degrees. That's all I need to remember, that the opposite angles add to 180 degrees. That means that A plus C give you 180, B plus D give you 180. All right, okay. Any other facts? So here we are. Here we are. Now, what is the angle of WXY? What's the angle of WXY? What's the angle of WXY? From Tasha, type in the answer to. All right, I got Kirin's response. What about the others? Torpedo. Try again. Try again, torpedo. Try again, torpedo. Try again. All right. Lexi, Nikosha, Kirin, you're all correct. Very good. What about Tangini and Tarsha? Tarsha is not in here. Tarsha's having some serious internet problems there. No Tangini, that cannot be correct. The information just told you a while ago that opposite angles add to 180 degrees. It did not say that opposite angles are equal. So it could not be that. Alicia, you're correct. Let's look at it. Good attempt, Tangini, good attempt. There it is. Opposite angles of a cyclic quadrilateral add to 180 degrees. Now, Tangini, let me warn you. Make sure you walk with a geometry set. That means you want to secure and make me happy. Make me happy come September morning. I want to be one of the happiest men on earth. Now, walk with the geometry set. Draw about the same shape. Measure the angles, all the angles then, and let it tell you the answer. That's one trick. One of the tricks to this thing, you draw about the shape that they give you in the exam. And a matter of fact, during the marathon, you're going to be exercising some of these tricks that I have with my sleeves. All right? To secure that pass in the exam. Know yourself. Now, you draw about the same shape, you know. And you can even draw with the same angle too. And you draw about the same shape. And then you troubleshoot with it. But you have to practice these things in the exam. Sorry, before the exam, practice them. And you say, all right, that angle is that angle is that angle. And you troubleshoot. Good? So you have to experiment to learn a lot about these things. Okay, Gabriel, you're also correct. All right. So make note of these things. You're going to need them for the worksheet. So we're almost finished. We're going to do some of the multiple choice, 10 multiple choice questions that are there. So make notes before we go to the other worksheets. So make note of it. All right. Now write this information down. You're going to need it. Tangent angle. A tangent. Can somebody read the sentence for me? Both sentences, please. Hello.
Tangent
Yes.
angle. A tangent line just touches a circle at one point. It always forms a right angle with the circle's radius.
All right. Basic information. And you can test it for yourself. It's all about drawing, using protractor to measure these angles and test them. All right. So let's go. Let's look at these 10 questions and see how much we understood. All right. So 10 multiple choice questions. Each person must try it. Any answer? Save them, boy. Come again? What's the answer?
Oh, sorry, I was saying if you could scroll down.
Scroll down. How come? All right. So one person put in their answer. Okay. So, all right. So Nikosha says that. Okay. Wait another other persons. Lexi says the same thing. Okay. That's two. Torpedo says the same thing. Okay. The three persons saying the same thing so far. Anybody else? Queuing. It shouldn't take that long. Okay, very good. What about Tangini? So Lexi says that. So the Kosha, Lexi, Queen, and Torpedo. Gabriel McPherson says the same thing too. Come Tangini, waiting on you. Come. Okay, very good, Tangini. So the answer is 64. Well done. Well done. All right. So everybody got that correct? Job well done. All right, so let's move on to our next question. Here we go. Here's the big question. Okay. Da, da, dee, da, da. That one. This is a tough cookie. Okay, let's get into some answers here. Okay, so all right, Lexi says that. And Tangini says that. Lexi and Tangini saying the same thing here. Waiting on Nikosha and Kiwain. All right, Torpedo says that. That's it. Let's see who's correct. Da da dee, da 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 dee, da da dee, da da dee. Okay, anybody else? Lexi, Nikosha. No, I mean Nikosha and Kiwain. But they're thinking this one out, you know? Thinking it out. Yes, indeed. So, Nikosha says that. Okay. So, Lexi and Tangina have the same answer. Nikosha has that. Torpedo has that. Kiwain, what says you? Okay, so wow, like seriously. That means set. So therefore, all right. Oh, Kiwain is thinking. Okay, Kiwain, think away. Think away, Queen. Think away. The torpedo says that plus that equal that. Then simplify. So Lisa said that. Okay. This will hold you. Shouldn't hold you at all. It shouldn't hold you at all, you know. It should never hold you at all. Can't hold you at all. Shouldn't hold you at all. I like the explanation, bossy. Well, all right. So young DK out says that. Okay. Now, so some person say 45 degrees. Some person say 30 degrees. Who is correct? Who is correct? Some algebra is yeah. All right, let's see. Now, if it is that this, it said that this angle up the corner there, so is twice this angle here. So let us call this angle X. And the next one is plus 2x. And we know that this is 90 for sure. And everything you're supposed to add up to. Yeah, Lexi, you change your mind. You change your mind, Lexi. Yeah? You change your mind now. Too late. 3x is equal to 90. Because you have to take 90 from the 1, it give a 90. Very good, torpedo. So the answer then is naturally x is equal to 30 degrees. So let's click on the right answer. Excellent. Let's go to the explanation. Not using the eyes at all, and now think. Since AB is the diameter of the circle, it divides the circle into two semicircles. The angle in the semicircle theorem tells us that ACB is 90 degrees. And the angles of the triangle are to 180 degrees. So the remaining angles must add to 90 degrees, naturally. Must add to 90 degrees. So therefore, if ACB is 2 times that, and they add to 90 degrees, then it must be 30 degrees and 60 degrees. Good? But the one that I showed you would have been the best method to use to figure it out. All right, nice try. Yes, QA. Yes, QA. Nice try. Who got it correct? Nikosha got it correct. Well done, Nikosha. Excellent. All right, let's move to question number 3 now. So, this goes without saying, eh? No. Here's a question. No. This goes without saying. Everybody's supposed to come and answer quick and fast. This goes without saying. This one goes without saying. Goes without saying. All right. Okay, Tangini. Oh. Okay. Kirin, show you one. Oh. Okay. You better say no. Yeah, mama scratch that long time. Torpedo. Wrong panda one, the torpedo. You wrong panda one there. Wrong panda one there. Very good, Tangini. Applying the principle. Tangini got it correct. All right, now you get it correct now, Kiwin. What about Lexi and Nikosha? Lexi and Nikosha. Yes, man. Thank God for that. Yes. Lexi and Nikosha, what about you guys? Okay, Lexi got it correct as well. Sorry, Kiwin. Sorry. All right. So Lexi gave what Nikosha? No, that is wrong. That is wrong, Nikosha. You get crazy now. Remember, you know, the rule says that the angle here is half of 98. So if you divide 98, how you get 82? It must be 49. You have to apply the center theorem. Okay. Gaming. That seems like Raquel. That's Raquel. Gaming. Very much correct. Job well done. All right. So let's move on to our other question now. All right. This is easy. Easy one, this. Easy 1, 2, 3. Easy 1, 2, 3. Easy 1, 2, 3. This. Easy 1, 2, 3. This is easy 1, 2, 3. Easy 1, 2, 3. Okay, Tangini, right off the bat. Who's next? You're correct, Tangini. Alicia, Torpedo. Alicia, that wrong long time, Alicia. That wrong long time. That wrong long time, Alicia. Try again. Wrong long time. Try again. Rules apply. Nikosha, you're correct. Lexi, you're correct. QA, okay, everybody correct. Answer is 84. Romeo, you're correct, Romeo. Very good. And Torpedo, you're now correct. The answer is 84. You just have to apply the rule, right? Very good. Next question, number 5. All right. Think upon that one. Let's see what's the size of WZV. W. Sorry, VZW rather. VZW. What's the size of angle VZW? Okay. Okay. So I use one, this one. Use 1, 2, 3.
So can I see the responses?
Oh, you mean responses? Okay. There they are. Right. Okay, Romeo have an answer. Let us wait on everybody else, Romeo. All right, Queen have the same answer as Romeo. Okay, well, we shall see. We shall see. Waiting on Nikosha's answer. Lexi and Tangini. Torpedo has that. Okay. So Romeo has that. Torpedo has that. Hold on, please. Hold on, please. Hold on. All right, so get some. All right. All right. So Lexi says to think that is the answer. All right. Anybody else? Tangini got that. Let's see what YouTube is saying. So Torpedo says that. Nikosha says that. And Young DK out says that. Well, let's see. So let's see who's correct. All right. Wait, so let's see what's going on first of all. Let's see what's going on. So QN says C. Lexi says she think A. Tangini says C. Nikosha says C. Torpedo says D. Romeo says C. And Young DKO says C. Who is correct? Let's see if it's C. Well done. Well done, Tangini. Wow. Very good. You're right. Well done. Well done. Well done. Well, let's look at a few things here, Lexi. Let's look at a few things here. Note that angle V, the angle at V and angle at Y is equal. Right? Now, if you add the angle right here to this, let's experiment a bit. Let's look at a little experiment. Eh? When you add 72 to 38, how much you get? 72 to 38, how much you get? Young DKO, 72 plus 30, you get 110, right?
Yes, sir.
So the angle at Z would be what? When you take 110 from 180, how much are you going to get? Get 70. Yeah. 70. Good. All right. Okay. So 70. So they are saying that WV, VWY, and VXY are both subtended by the same arc, VY. See? It's subtended by this. Remember I told you that earlier. So once they are subtended by the same arc, they're going to be equal. So we use up the theorems. Good. You have to use up the theorems. Now, it goes further to say the angles subtended by the same arc theorem tells that the angles are equal. Good. So therefore, therefore, VWY is equal to 38. Good. VWY is equal to 38. So this is 38 right here. So good. Now let's continue. So the same angles are 38 degrees. So you could use that one as well. And now you use the angles of the triangle. 72 plus 38. Get 110. And then you subtract it, get the 70 degrees. Simple. All right? Simple as that. Make sense? Make sense?
Yes,
All right.
sir.
Yes, sir.
Okay. Very good application of the rule there. All right. Let's look at this one now. All right.
Sir,
So, yeah, go ahead. You answer the responses? There they are. So we have two persons having the same responses. So we want to find the angle form at A. So DAX. All right, let's see. Let's see what persons are coming up with. All right, Tangini again. All right, Nikosha. Tangini again. Kiwi and have that answer. Okay. So Tangini and Kiwi have the same answer. And we have Torpedo and Romeo with the same answer. Let's see. Let's see. Nikosha have the same answer again. Lexi, where's yours? Come, Lexi, waiting on yours. Okay, all right. So everybody have the same answer. Hope you never guess that one there. Hope you guess that one there. Did you guess it? How you work it out? Hmm?
No, sir, I didn't invest it.
You never get it another. You work it out. Okay. All right. Okay. Oh, somebody is wrong. So let me check it for myself. All right. So let's see if you all are correct. Congratulations. That is the right answer. Very good. Wonderful. Ta-da! Same rule applies. Congratulations, Star Peter and Romeo. You guys are doing well. Question number 7. Easy one again. Easy 1, 2, 3. Easy 1, 2, 3. Come on, come on, come on. Easy 1, 2, 3. Easy 1, 2, 3. Easy 1, 2, 3. This. Huh? This one looks like a tough cookie, don't it? Easy 1, 2, 3. This one. All right, Kevin, right off the bat. That's correct. All right, Romeo. Let's see if you are correct. Lexi, Nikosha, Tangini, what about yours? Waiting on you, Tangini. Torpedo, yes. Tangini, are you there? Where's your answer, Tangini? Waiting for you. Okay, well done. You all are correct. Congratulations. Very good. Very good. Supplementary answers, eh? Number 8. Let's see. Let us see. VWZ. 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 So here's V right there. VWZ.
So can I see the responses, please?
Come again? Scroll down. Okay. See if you guys are thinking. VWZ. Okay, Torpedo said that. Okay. Kirin says that. Nikosha says that. What have a different answer to that? So Nikosha and Lexi have the same answer. Kirin says that. Okay. And I see 3 persons in Torpedo Romeo having the same answer. So let's check the answer and see if it's correct. Trying to get my calculator to work. 1 second here. Okay. Densmore Carr says B. All right, let's say B is correct. Now, first of all, the rule here that you have to use two rules. Two rules you have to use to get that answer. First of all, bam, bam, bam. Hold on there. Bam, bam, bam. Bam, bam, bam. Give it that. The people them said D wrong. These ultimately wrong. D is ultimately wrong. So QN. Your eyes are working tonight. Lexi, have your answer? Tangini, where's the answer, Tangini? You don't give me an answer, Tangini. Tangini, have you answered it? From Tangini, trying to give you a chance. Okay, Tangini says B as well. The answer is 83. Those who got 83 is correct. Why 83? Let me explain. Note that this angle is opposite to this angle. So based on the cyclic quadrilateral rule, they will have subtract this from 180 to get 97. But they ask for the angle on the outside here. The angle on the outside here and the angle on the inside here forms a straight line angle. And angle on a straight line is 180 degrees. So if you subtract that 97 from the 180, you're going to get back 83 degrees. Wow, good, wonderful. See, here you go. Cyclic, supplementary angles 180. We add them, got them right there. Got them right there. And a straight line, those are the two. All right, so we have two more questions to go, and then we'll be closing the curtains for tonight. Tonight will not be any quiz or quizzes. As those in YouTube continue to, we do appreciate your participation each night. I welcome back like Romeo and Torpedo, Desmore Carr, DK Oates. Welcome back, you guys, to our classes tonight. Thank you for supporting the class. And of course, our usual supporters. Gaming, thank you for coming back as well. And we also say thanks to Gabriel McPherson for coming to supporting the class tonight, Alicia as usual, and of course, Teresa, one of our students. So just to take, while you guys try to solve the question, just to say a little bit more about we start our marathon tomorrow night. Now, each night is a section of the syllabus. We start the drum rolling tomorrow with vectors and with vectors. So all of our thing will be on vectors tomorrow. Vectors, and all about vectors. The following day, we're going to go on matrices, all about matrices. And we keep going up until we reach section 1, or section 1 of the syllabus. So we're coming from the last section to the first section, and over a 2-week period, we'll be through. If you want to get access to this class, all you need to do is to send a WhatsApp number, and I'm going to put it in the chat. The WhatsApp number is 1-876-324-8441. So if you want to be a part of the marathon, it is 1-876-324-8441. So the maths marathon begins tomorrow, and we go all the way throughout the week, except for Friday nights. And we will be considering Saturday nights and Sunday nights in those 8 days over the 2-week period. We'll continue our math streaming on Monday, though, to facilitate Mr. Foster's. And of course, He has been a blessing to CDP Library Services so far. We do say I continue to say publicly giving him thanks for what he has done and what he continues to do for CDP Library Services. But he was unable to make it tonight, but to God be the glory, we're still able to get this part of the job done. So as we continue, Romeo says that I see your answer, Romeo. Waiting for the other persons. All right, Tangini says that as well. All right, Nikosha, where's it? All right, Lexi says the things that. Okay. Okay. Well. Well, all right. So where's your answer? So I have Tangini, I have Lexi, Romeo has that. Let's see if everybody has the same answer here. So Lexi and Tangini have the same answer. What about okay, sir. Well, we have one more question to go after that. This one is weird. Is it weird? Are you sure? Well, well, well. So most persons think the answer is that. Torpedo, what do you think? Nikosha says that. Really? Well, no. So some person says that is the answer. Okay. So they want you, and B might just be the answer. Lexi says, Lexi, change your mind?
That one you're confused because first I look on it one way, then look on it another way.
All right. So Torpedo says that. Romeo says that. All right. Well, let's go what most persons vote for.
Hold on.
Hold on.
Something just clicked to me just a while ago. Hold on.
Okay. All right. All right. Well, I'm holding on. I am holding on. I am holding on. So it's easy. Yeah.
It's like easy to you, sir. You study for this.
No, I'm eyes me use. You can't still don't want to use your eyes. You're about study for this. You better don't want to use your eyes now. Stand don't want to use your eyes then. If you use your eyes.
Sir. I know why y'all laugh, sir. Sir. You're the boss both pick 50 and 50 probably wrong.
Nikosha the boss.
Sir, may I try to answer to you, sir?
All right.
May I try my answer to you?
All right. Let me save the answer right. Let me save the answer. Type your answer to me. Bam, bam, bam. All right. Okay, QE. Let's save that answer is correct. Bam, bam, bam. Yes,
yes,
boss.
Yes. Hell yeah.
Very good. Well done. 70 degrees. Right.
Oh my God.
You know why 70 degrees? Tell you why. Remember the two line of my tangent in the boss. You understand? So the 90 plus 90 are 180. And remember, say you're gonna have a quadrilateral being formed. So
yes, sir. That may look but then, sir,
eh?
you know, so, beat more still because me I look on it and me I say to myself, say, Hold on there. I want quadrilateral this. Me I look on it, I think says I want triangle. Yes. It is a SRT. I want triangle. Me I say,
What
hold
is
on
a
there.
triangle, me say?
No triangle, a
That's why I say
quadrilateral.
use your eyes.
Me look on it close and me say, but hold on there. A quadrilateral is for true, yo. I say, okay.
Yeah, but you have to
They
use your
use their
eyes.
head. They use their head for me.
Yes, man, but you have to use your eyes, man. Cause guess what? No, guess what? You have to use your eyes now. Cause when that's a triangle, we have to see quadrilateral too. You understand? I have to remember the other rules. Hey, the one are very compact. You see, so 90 here, so 90 here, so and you add this, so you get no 140 for this now, but at this angle I want. So half of the 140 got to be 70 degrees. Nice try, Romeo. Nice try, Torpedo. But the answer is 70. Yes, Nikosha. All right. Yeah. All right. Begin Nikosha that one because she get it right on the spot. All right. What job well done. Congratulations. See that? Straight. So you use the quadrilateral, some of 360 degrees, RST tangents, so at 90 degrees each. Bam, 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 bam. And then use the angle center. Bam, 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 bam. Final question for the night, and they will shut it down. They will do evaluation for the night's class. So we didn't get to do worksheet 1 and 2, but of course, a day will come when you'll be able to get to do it. Number 10 and final question for the night. Well, don't boss.
Another one. No, 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 sir. Take this off. Why this still so?
Well, they want to find the angle SRT.
Oh yeah, man, see it already, man.
Okay. Remember now when we go back on circle theorem, we'll hit the possible questions. Please remember to ensure of your geometry sets because we'll be using the geometry sets to move forward and cement the deal on the circle theorem and pack it away and put it by itself. So please remember to have that. So we'll be doing geometry and trigonometry on our third night. That should be Thursday night. All right. Q&A, raise your hand. Go ahead.
Sorry, you can just scroll down, please, so I can see.
Okay. You have the answers. Are you ready for the answer? Ready? Voila. And while you guys are battling this question, while you're battling this question out, want to congratulate, want to say, well, Romeo has an answer right there off the bat. Let's see if he's here, if he's correct. All right. For those on YouTube, just want to remind you that at the end of the class, we ask for an evaluation, meaning that you give us a feedback on the class in the chat, and of course, express your feedback by liking. Click on the like button if you're correct. Leave a comment as well. All right, so we see Nikosha, QA and Nikosha has the same answer. Let's say Nikosha will get this one right as well.
See, when me and Nikosha have the same answer, and you know what that means, you know.
That means it right. Okay, then we shall see. Voila! Oh, so what's going around here? And Romeo have the same answer too. So what's going around here? Let's them change the pound, don't it? that, and that. So I'm the Lexian Tangi. Come in for the party to the man. Come in for the party. Come in on the party, ladies. Come in on the party. All right, so bam, 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 bam. All right, so yeah, man. Another boss. Torpedo. Let's see if we get this one right this time, boss. Come, Lexi, and and Tangini. Come. I wait for you. Come join the party for now one. I just no one glasses for now one. So I hope you have somewhat learned more about the circle theorem tonight. Just have to practice. We're going to cement the deal with the drums set to ensure that you're correct. Lexi and Tangini, we're waiting on you guys to give us your responses.
I'm looking. Scroll down back, let me see what it asks for again.
Hello. Nobody can feel like saying that the exam, they might have multiple choice here. So you better get it right. Oh, the multiple choice paper to have multiple choice. All right. But you are gobble up the marks them. Oh, Tangini, that worksheet you have to redo it. 'Cause I'm not seeing it properly. It's not. So you have to re-upload it. You're Tangini.
Yes, sir.
And I expect you, Lexi, to move on to measurements and fly through it and get to statistics.
I started.
Oh, fly through the statistics afterwards. Run fast. Woo. Start sprint now. Sprint away. All right. So what is the size of SRT?
Sir, I do not know.
Where is it, Lexi? Lexi, where is it?
Sir, I don't get this one.
You don't get this one? Like seriously? Seriously, Lexi? Can't believe it. Come Tangini, try. Try Tangini, come. All right, while we take a wrap on this class tonight, just want to ask those in YouTube just to leave in the chat what's your feedback about tonight's class, what you think about tonight's class, and of course, express how you feel about it, as you know, right there. All right. Tangini, should I pull the plug?
Sir, if I'm going to give you an answer, I'm going to guess my way out.
Oh yeah, guess it we out. All right, you don't want to guess it we out. At least you're honest. Totally honest. And again, it's the same thing. This is 90 degrees, and it's a quadrilateral. 1, 2, 3, 4 sides. Now this is 72, so this must be twice. So this is going to be 144, or so go. 72 plus 72 is 144. So 144 plus 180 is 324. I take 324 from 360, you will definitely get 36 degrees. So the answer is 36 degrees. Good try. Well done. Congratulations. So that was the final question for the night. All right. So this means that you guys will definitely. Oh, you got it, Lexi. Okay, I understand it now. Oh, you got it. But I didn't want to say what the answer was, eh? All right. How was tonight's class? Starting with Nikosha. You can text your answer in. QA, you want to go next? I guess Nikosha will type in hers. You have a microphone problem. What you say about the class tonight, QA?
Tonight's class was very, very good. Enjoyed it.
Okay, very good. All right. Nicole says excited. Okay, good. All right. So Nicole says exciting. QA says very good. He enjoyed it. What about you, Lexi and Tangini?
Seriously asking these ladies.
Yes, man.
Your class was good.
Class was great. Okay,
Yes,
thank you
sir.
very much. Okay, wonderful. Tangini.
I actually learned. I know I have a thing against circle theorem and actually learn.
You actually learned it. Okay. All right. Good. Very good. Very good. Yes, Kevin. Okay, gone now. Yes. I'm getting better. Improvement. Yes, I'm getting better. All right. And Tangini says class was fun. All right. So Romeo says class was wonderful. And Densmore Carr says class was good. All right. I appreciate those comments. Torpedo, what about you? What about you, Torpedo? All right. So, guys, remember now that we look forward for a very good. Okay, I agree, Lexi. Okay, all right, good. So let's take some more practice. So, of course, we're going to build the confidence some more with the possible questions. These 10 questions were just to ensure that you will practice on it. Because remember now, we're going to hit the road hot when the exam come. You understand? So don't worry yourself. We're going to get there. I'm going to do well. Okay, then more says you just get 8 correct. Well, 8 out of 10, not bad. Still a good try. Congratulations to you, Miss Carr or Mr. Carr. Then more Carr. Congratulations to you. Torpedo says I need improvement on this topic, but the class was great. You're welcome, Torpedo. All right. Now, and Alicia says, I haven't done this topic before. I really do enjoy the class, sir. Gonna enjoy doing maths next year. Learn a lot already. Well, Alicia, I hope you come to maths with us now. Since you're going to do maths next year, hope you come to maths with us, Alicia. Hope you join CDP Labs for maths class next year. Hope so. All right. Okay. So that is it. We start the marathon tomorrow night at 8:30. And guys on YouTube, the marathon will not be streamed. But if you want to be a part of the marathon sessions, then you can WhatsApp me at the number I gave in the chat, 1-876-324-8441. If you want to be a part of the marathon, just send me a WhatsApp message and I will give you further details on that. I do appreciate the comments made by those persons in YouTube and of course from the family in Zoom, CDP Labs Edu Services family. And without you guys, this class would not have been what it is tonight. All right, so that's a wrap. You guys can leave. Or let us, we should end this class with our theme song and close it off with a theme song. So God has been good. Good night, Coach. Okay, Cara, I got you.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God.
All my life you have been
'Cause all my life you have been faithful. And all my life you have been so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice.
led me through the fire.
You have led me through the fire. And in darkest night,
Like no
you were close like no other.
You are the Father.
in the goodness of God. Yeah.
All my life,
And all my life you have been faithful. And all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. Yeah. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running, it keeps running after me. And all my life you have been faithful. And all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. I'm gonna sing, I'm gonna sing. Oh, 'cause all my life you have been faithful. And all my life you have been so, so good. With every breath that I am able, oh, I'm gonna sing of the goodness of God. Oh, I'm gonna sing of the goodness of God. With every breath, oh, for all my days.
Guys, that's a wrap. Good night.